Many natural gas reserves are considered stranded resources. This is because these reserves are located where it remains either uneconomic to produce the gas or there is not yet sufficient infrastructure in place to transport the gas onto a natural gas processing plant. In fact, where natural gas is produced along with oil and cannot be sold or stored back underground, the gas may be burned or flared. This flaring is done for safety reasons. Burning the gas keeps it from exploding. Over the past several decades, many formerly stranded natural gas resources have been brought online as world consumption of natural gas has more than doubled. This doubling is in part because of the increasing demand for all forms of energy by a growing global population with rising living standards. But demand for natural gas has also been increasing because it's a much cleaner burning and thus potentially more environmentally friendly fuel than coal, which globally remains the dominant fuel burned in generating electricity. To meet the rising international demand for natural gas, liquid natural gas plants have been built in countries with large, relatively easy to produce natural gas reserves that until recently have laid untapped due to little, if any, domestic need for the gas. These countries include Qatar, Malaysia, Australia, Indonesia, and Nigeria. Turning natural gas into liquefied natural gas, or LNG, raises the energy content per unit volume of the gas almost 1,000-fold. The energy density of LNG approaches that of propane and gasoline. Liquefaction of natural gas is accomplished in long, massive refrigeration plants. The plants remove any impurities from the gas and then compress and supercool it into a liquid with a temperature of minus 161 degrees centigrade or minus 258 degrees Fahrenheit, which is the boiling point of methane at atmospheric pressure. The plants are known as LNG trains because of their train-like shape, particularly when two or more of these plants are coupled together at large liquefaction facilities like at Ras Laffan in Qatar. The LNG is then moved from the plant onto specially designed LNG carrier ships. LNG carriers take several forms, but all have 4 to 6 large thermos-like tanks located down the center line of the ship. Combined, these tanks hold 250,000 cubic meters or so of LNG, which is the equivalent of 5.4 billion cubic feet of natural gas. The LNG carrier transports the liquefied natural gas across the ocean to a regasification plant located at a port in the country importing the LNG. This, for example, is a regasification plant in Tokyo, Japan. At such sites, the LNG is converted back to natural gas through gradual warming. The imported natural gas is then readily injected into the country's natural gas transmission and/or distribution system. As the LNG component to the midstream sector of the natural gas industry has expanded, natural gas has increasingly become a globally traded commodity. As a result, the availability of LNG is altering traditional natural gas markets throughout the world.